So concrete, I wanted to take a quick side note and talk about some history of it. Um, Became widely used in the Roman Empire. There's even a reference by a Roman architect in 25 BC where he's talking about different uses and different aggregates that can be used in concrete. And the first structures date back to 6500 BC in southern Syria and northern Jordan. Um, when I visited Rome, I saw the Pantheon. It's an amazing structure. To imagine it was built, by hand utilizing concrete that long ago is pretty impressive. It's still the largest unsupported dome in the world, and it was the largest dome in the world for 1,300 years. So it's pretty impressive. Next, aesthetic appeal of concrete. So GFRC, or glass reinforced concrete, is pretty widely used. It's utilized for exterior cladding, decorative panels, and column covers, which all add to the aesthetic appeal of a structure. Concrete can be formed into, really countless configurations to get pretty amazing effects. And there's numerous different finishes that can be applied to the concrete while it's curing. I listed a few here. The most common that we see on sidewalks, driveways, things like that are broom finish. Also, the exposed aggregate right now is pretty popular, where they'll basically spray some kind of acid on the concrete that takes off the upper finish and exposes that aggregate. So functionality. So concrete, before it sets up, is obviously fluid. It can be pumped to its final destination, especially in really difficult work environments. This can extremely lower the labor costs. A lot of times in commercial properties, you have what's called tilt-up construction, and concrete panels can be pre-cast on or off-site and then tilted up into place. Concrete strength increases over time through a chemical process called hydration. So essentially, the longer you leave concrete alone and keep it moist, the stronger it's going to be. It can double in strength in approximately 20 to 30 days. Structural integrity. So concrete's really good at supporting compression loads, but it's not so good with like lateral tensile forces, which can cause concrete to shear. That's why we reinforce it with rebar, wire mesh, a couple other systems. Ultimately, these two materials, rebar and concrete, work together to resist forces that, separate from each other, they would either bend or break apart. Durability. So there's a direct link between a concrete's durability and its water-cement ratio. The most destructive natural weathering force is freezing and thawing, while concrete is wet or moist, because of the expansion of water expansion of water as it changes to ice. It's a quote from Olin's Construction, the 9th edition. Next, it is not possible to entirely prevent cracks in concrete. They're gonna form. What typically is used, or is a common construction practice, is to use control joints, and this really, directs the cracks away from vital areas like columns or something that's going to be supporting the structure. and that it also allows for some movement of slabs and volume changes. Reactions and relationships with materials. So admixtures are materials other than Portland cement, aggregates, and water that are added to alter the properties of concrete. So during that mixture process on the truck, or if you're mixing it by hand, these can be added. They can improve workability, so allow it to be a little easier to spread and work. It's starting to thicken up on you. It reduces the separation of aggregates and trains air. And they can accelerate or retard the setting and hardening process. There's a ton of different admixtures, and their effects can change with how how much water's in the concrete, how much aggregates in the concrete. So typically something like a concrete engineer or something like that deals with admixtures. Concrete and steel are chemically compatible. That's why we use rebar in concrete. The alkalis in concrete protect the steel from rust and corrosion. And they have a similar coefficients in expansion and contraction. So basically, you're not getting steel expanding at a faster rate than concrete and cracking concrete around it. A couple metals and alloys that are not good to use in concrete are copper, zinc, aluminum, lead, and galvanized steel. Basically, if you embed or they come in contact with concrete, they can begin to corrode faster and can ultimately damage the concrete as well. There's a couple photos here on the right that just show a couple metals that are dissimilar and have common contact with concrete. And that is it. Thank you.